Hi, this is King of Review. In this problem, we want to solve the system of linear equations by using Cramer's rule. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use Cramer's rule to solve this system. That is, solve for x and y. So Cramer's rule is a method where we use determinants to solve a system of linear equations. Cramer's rule states that we can find x by taking the determinant of the x matrix and dividing it by the determinant of the coefficient matrix. And likewise, we can solve for y by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So what are these matrices? Let's first look at the coefficient matrix. The entries in this matrix are the coefficients of our x and y terms. So A, B, C, and D. The x matrix, this starts with E and F. And you can see that E and F are the constants of the two equations. And then we have B and D. And then the y matrix, this is equal to A, C, E, and F. So this is how we set up the matrices. So let's set them up using our specific values. For the coefficient matrix, if we look at our system of equations, the coefficients are 2, 3, 1, and 1. So 2, 3, 1, and 1. For the x matrix, we're starting with E and F. Those are the constants, so 4 and 1. And then we have B and D, 3 and 1. And then for the y matrix, we have A and C, so 2 and 1, and then E and F, 4 and 1. So now we've set up our three matrices, but you notice Cramer's rule states here that if we want to solve for x and y, we need to have the determinants of our matrices. What is a determinant? Well, a determinant is a real number associated with a square matrix. So let's say we have a matrix with entries A, B, C, and D. If we want to find the determinant, we're going to start by multiplying the entries in the main diagonal, so AD, minus the product of the entries in the other diagonal, CB. So AD minus CB, this is how we find the determinant. So to find the determinant of our coefficient matrix, we're going to take the product of the main diagonal, so 2 times 1, and subtract the product of the entries in the other diagonal, so 1 times 3. So we have 2 times 1 minus 1 times 3, and when you work this out, you get a negative 1. Now let's find the determinant of the x matrix. We take the main diagonal here, so 4 times 1, and subtract the product of the entries in the other diagonal, 1 times 3. And this equals 1. And the y matrix, we'll take the main diagonal, 2 times 1, and subtract the product of the entries in the other diagonal, so 1 times 4. And this is equal to negative 2. So now solving for x, the determinant of the x matrix, we solved for that here, that's a 1, divided by the determinant of the coefficient matrix, that's negative 1. So this equals negative 1. X is equal to negative 1. And now for y, the determinant of the y matrix, we solved for that, that's negative 2, over the determinant of the coefficient matrix, that's negative 1, and this equals 2. So y is equal to 2. So we've solved the system using Cramer's rule. Letter C is correct. Thanks for watching.